can you solve this Math Olympiad challenge? Here's the question. Find a polynomial with integer coefficients having fifth root of 2 plus square root of 3 plus fifth root of 2 minus square root of 3 as a root. So pause the video right now and see if you can answer this question. And of course, if you're done, post your answer on the comment section down below. Now let's see if you got the correct answer. Alright, so our goal in this question is to find a polynomial with integer coefficients having this expression as a root. Now, to answer this Math Olympiad question, what we're going to do is to take this expression and let b equal this to x. So now, we can rewrite our polynomial equation as follows. We have ax raised to the fifth power plus bx raised to the fourth power plus cx cubed plus dx squared plus ex plus f equals 0, wherein a, b, c, d, e, and f are all integers. So, our goal in this question is this polynomial equation. So, how do we get this polynomial equation? So, to do that, first, let y be equal to fifth root of 2 plus square root of 3. Now, what we're going to do is to raise both sides by 5. So, we have y raised to the fifth power equals 2 plus square root of 3. Now, notice that 2 minus square root of 3 and 2 plus square root of 3 is conjugate of one another. Because if we multiply 2 plus square root of 3 multiplied by 2 minus square root of 3, this is just 1. Meaning that 2 plus square root of 3, we can rewrite this as 1 over 2 minus square root of 3 or vice versa. 2 minus square root of 3, we can rewrite this as 1 over 2 plus square root of 3. So, we can say that 1 over y raised to the fifth power, or the reciprocal of y raised to the fifth power, is just 2 minus square root of 3, or the conjugate of 2 plus square root of 3. Now, focus on this equation. If we take the fifth root on both sides, so we can have that 1 over 5 equals the fifth root of 2 minus square root of 3. And this is just this 2 expression right over here. Now, if we add y and 1 over y, this is just fifth root of 2 plus square root of 3 plus fifth root of 2 minus square root of 3, which is equivalent to our x. So we can rewrite x as y plus 1 over y. This is very important. Now, using those results, our goal now is, again, this polynomial equation having an integer coefficients. To get this equation, what we're going to do is to add these two results, y raised to the fifth power and 1 over y raised to the fifth power. And if we do that, we eliminate this negative square root of 3 and positive square root of 3. So this is just y raised to the fifth power plus 1 over y raised to the fifth power equals 4. Now, let's focus on this equation. So our goal now, to rewrite the left-hand side as y plus 1 over y, and then replace those y plus 1 over y with x, and we are done. Alright, so to do that, y raised to the fifth power plus 1 over y raised to the fifth power is equivalent to y cubed plus 1 over y cubed multiplied by y squared plus 1 over y squared minus y plus 1 over y. Why we have this one? Because it's just 3 plus 2 is just 5. Now, let's verify this result. If we multiply this 2, we have something like y raised to the fifth power plus y plus 1 over y plus 1 over y raised to the fifth power minus the quantity y plus 1 over y. And take note, y and negative y cancel out, 1 over y and negative 1 over y cancel out. So this is just y raised to the fifth power plus 1 over y raised to the fifth power. Therefore, this is just equivalent. So we can rewrite the left-hand side as this one, this expression, y cubed plus 1 over y cubed multiplied by the quantity y squared plus 1 over y squared minus the quantity y plus 1 over y. And then, take note, when we square 1 plus 1 over y, we have the result of y squared plus 2 plus 1 over y squared. And rearrange some terms a little bit, we get the value of y squared plus 1 over y squared. So subtract 2 on both sides, and we get that y squared plus 1 over y squared is just y plus 1 over y raised to the power of 2 minus 2. So we can replace this with this equivalent, like this. Finally, if we cube 1 plus 1 over y, we get y cubed plus 3y plus 3 over y plus 1 over y cubed. Now, factor out 3 in these two terms. We have 3 multiplied by the quantity y plus 1 over y. Now, rearrange some terms a little bit to get y cubed plus 1 over y cubed. And this is just y plus 1 over y cubed minus 3 multiplied by the quantity y plus 1 over y. So we can replace this with this equivalent that consisting of y plus 1 over y only. Now, focus on this equation and see y plus 1 over y is just x. So we can replace this with x. This one is with x, this one with x, and this one with x. If we do that, we get x cubed minus 3x multiplied by the quantity x squared minus 2 minus x equals 4. So, y plus 1 over y, this becomes x. All of them becomes x because we don't want a polynomial equation in terms of y, but we want a polynomial equation in terms of x. So now let's focus on this result, and if we expand this, or if we multiply this, we have x raised to the fifth power minus 2x cubed minus 3x squared plus 6x, then bring down negative x equals 4. Now combine like terms, negative 2x cubed minus 3x cubed, this is just negative 5x cubed, 6x minus x is positive 5x, then equals 4. Now let's focus on this result, and the final step, let's subtract 4 on both sides. So we have this quintic equation raised to the fifth power x raised to the fifth power minus 5x cubed plus 5x minus 4 equals 0. And someone on the comment section maybe verify this result, that this quintic equation, the root of fifth root of 2 plus square root of 3 plus the fifth root of 2 minus square root of 3. And this is our answer to this question. And as always, we are done.